Part 3 of example 1, correlation and linear regression. This says determine the regression line that relates the number of hours of absence, which we've called X, to the final course percentage, which we've called Y. All right, line. In algebra, you learned that a line was Y equals mx plus b. And back in algebra, your job was to find the m and the b. M was slope, b was y-intercept. I would have asked you that you're not here to answer, but I'm pretty sure you would have remembered that. Now, let's talk about why did we just do that hypothesis test? We did that test to prove whether or not it was appropriate to use a line as a model for that data. And I want to remind you that the outcome of that test was, yeah, there is a linear relationship. So the point would be, you wouldn't even do this step unless you had previously proved in your hypothesis test that there is a linear relationship. So, we did that test to see whether or not it's now appropriate to make what they call a regression line. It's not my fault, but I just mentioned that in algebra, we call a slope m, but in statistics, we call a slope b. Weird, isn't it? And then in algebra, they call the slope b, but in statistics, they call the slope a. Weird, isn't it? All right, not my fault. I'm not going to apologize for it. But anyway, that's the deal. So just keep that in mind. So in statistics, when you find your slope, which is called b in statistics, it's a beautiful formula, and there it is. All right? And then to find your a, it's another beautiful formula, and there it is. Well, come on up. There. There they are. Okay, now, the thing is, so you're like, well, where do you get all that stuff? Remember that table we made a long time ago that I had to erase a long time ago with the green and red and blue columns and stuff that you have a copy of? We're going to look back at that. All right? So, look. But here's the thing, too. And I think this is worth noting here. The B value, the B formula, if you look at this, there's some similarities between these formulas and the formula we did earlier when we found R. So if you would go back to that slide and compare these, I know it's hard, you're flipping around, look for the one that says correlation coefficient with that circle there. Why reinvent the wheel? I would like to point out to you that the numerator, the formula for B, the numerator, is the same as the numerator of R. Wouldn't it be nice if we saved the numerator for R? We did. That's why I did that over here. Remember when I said save these things? This is why. The numerator of R is the same as the numerator of B, so it would be the negative 1590 that we calculated earlier. Yay! Why reinvent the wheel? Looking at the formula for the denominator of B, I hope you go, that looks like that first bracket when we did R. 252. All right? So you don't have to recalculate them, just recognize that that B formula has elements of it that were in the R formula that we did a long time ago. So save those. Save the numerator, save the two brackets, you're going to be able to recycle them. And so the math on that leads to an R value, or pardon me, a B value, which in stats is your slope. Stupid, isn't it? It's weird. All right? But you divide that out, and you get negative 6.3095. Notice it's got a negative slope, which the scatter plot suggests. That's why I keep leaving this up here, so you can see that this, yes, this thing should have a negative slope. All right, the A value, which goes here in statistics, well, I point out the denominator there is the same as the denominator B, which is that first bracket when we did R, which again would be the 252. Cool, why reinvent the wheel? But I will tell you that the numerator of A, sadly, is not anywhere available to us. So I would just suggest to you that you go back to that table you made a long time ago with all the sum of this and the sum of that and all this and all that, which, go back to that, and that would be that red and green and blue columns. Get out of the way, I can't see it, okay? Pull that up again, and now I'll put this formula up for the regression line. You can hopefully pick out with me the relevant numbers as we talk it through. So, the sum of y, wouldn't the sum of y, oh boy, sorry I'm flipping around. The sum of the y would be 459. I hope I'm looking at the right thing here, yeah. And then the sum of x squared, that'd be that red column, wouldn't it? 138. Minus sum of x, that'd be that first column there, that, if you recall, what's that add up to? Right, 24. Okay. And then the sum of xy, what color was that column? Yeah, green. And what was the sum of that? 1571. Crunch, subtract, blah, 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 divide, arithmetic. And off the top of my head, that should come out to be 101.7381. You keep however many digits you want. Okay, I don't care. Let's go 3 or 4. So that's mechanical stuff, and that would all be, again, be built off of that table that we made a while back. But let's also recycle some of these things when we did the R value. So there's what the math nerds would consider to be a decent mathematical model for this. And so you don't have to do this when you turn in your paper, and I'm about to erase this to make room. I guess I don't have to. I hope what you remember from your days in algebra would be that if we graph this, you would first of all say, okay, that's my y-intercept. When x is 0, y would equal 101.7, a little bit above 100. And then your slope would be what? Down 6.3 and over 1. Over 1! Down 6.3 over 1, down 6.3 over 1. And that would basically make this line here. And the stats nerds of the world are saying, you know what, you can use this equation here to predict a person's grade based on their absences. And so that's in fact what we'll now do with part B of this question. If a student were to come up to me at the beginning of the semester and say, hey there, Mr. Cedar Shingle, I think I'm going to be gone. I'm going to be absent 7 hours this semester. What do you think that'll do to my grade? I can say, well, look, you might be an outlier. You might not fall in line with my previous students. But based on the model that I've come up with, the typical student, if that student has 7 hours of absence, put 7 in for x, the typical student who has 7 hours of absence throughout the semester, put 7 in for x into the equation you just built. My model would predict that that person would end up with about a 57.5716%, about a 58%, let's call it, whatever you want to say. And again, there's outliers. Maybe that person can learn better on their own than the typical person, but if you're typical, that would be my prediction of your grade. That's example 1. All right, I think that we will do the same thing on example 2. We will come back and we'll go through the 3 parts again and give you another one of these to enjoy if you feel like you need it. And there are some little tweaks on example 2 that are a little different than this one, so I would recommend watching it. Okay, cool.